Hi everyone, Mrs. Nowakowski here. Today's lesson is all about how to solve a radical equation. So that's just an equation where there's a square root somewhere in the problem. So before we talk about square root equations, I first want to just do a quick reminder. If you look at the first problem, how would you solve x squared is equal to 9? So if you remember, we need to isolate the x. Since the x is being squared, we're going to take the square root of both sides, because when you take the square root of something that is a perfect square, that square root and that perfect square will cancel, and you're just going to be left with x. And when you take the square root of both sides, you have a plus or minus, and the square root of 9 is 3. So now if we change this just slightly, if we had the equation square root of x is equal to 2, we need to isolate the x. Right now the x is located underneath the square root, so we somehow have to cancel out the square root. In the previous problem, we already talked about how squares and square roots are inverse operations with one another, which means they cancel each other out. So if you want to cancel out a square root, you are going to square both sides. Now, whatever you do to one side of an equation, you have to do to the other to keep it balanced. So when you have the square root of x and you square it, that's just going to cancel out and just leave the x. And on the other side, when you have 2 squared, that's going to equal 4. So this new technique is something that we're going to be using a lot today when we're solving these radical equations. So if we look at example 1, it has a little bit more to it, but you're going to approach it the same way. Off to the right, we have the steps that you should follow to help solve these equations. So the first step always is to isolate the radical. So we want the square root as the only thing on one side of the equal sign, and everything else has to get moved to the other side. In the case of example 1, it's already isolated. Now, the next step is you want to make sure that the square root is equal to a positive number. Okay, when you take the square root of any number, square root of 9, we'll think of perfect squares, square root of 16, square root of 25, you're always going to get positive values for your answer. And if you remember, you're not allowed to have a negative underneath a radical because that's imaginary. So really, there's no way to take the square root of a number and have it equal a negative number. So if that's the case, you can actually say that there's no solution to that because it doesn't make sense. This is not an example where it's equal. If you notice, it is equal to a positive number, which means we are able to solve for x. Later on, I will show you an example when it's equal to a negative number. So the radical is isolated. It's equal to a positive number. So now we can take both sides and square it. The reason we're squaring it again is because that's the way to cancel out the square root. When you cancel out the square root, what's left is what was underneath that square root. And then 4 squared is 16. And now the only thing that's left is solve for x. So we're going to subtract 3 from both sides, and we're going to get that x is equal to 13. So the final step that you should always do for radical equations is you should always check your answer. There are cases where you will get extraneous solutions. Remember, extraneous solutions are solutions that when you plug it back into the original, does not make the equation true. So we always have to make sure that our answers work and make sense. So to do that, I always plug in to the original problem before we square both sides. So when we plug in, we get square root of 3 plus 13 should equal 4. This ends up being the square root of 16 is equal to 4. we already know square root of 16 is equal to 4, so this makes a true statement, so that means 13 is an actual answer. Okay, so that's pretty much the process that you're going to follow for all of these problems. The problems can get a little bit more challenging, and you'll see that as we go. But let's do the next two examples together. So first thing with example 2 is you have to make sure that the radical is isolated. So isolated means there shouldn't be anything being added or subtracted outside of the radical, or even multiplied or divided outside of that radical. So if you notice, we have this -1 out front, so we still need to isolate this radical. So we want to move that -1 to the other side. When you have a -1 in front of a radical, that -1 is being multiplied to that radical. So the opposite of multiplication is division. So you want to divide both sides by that -1. So you're going to get the square root of 3x minus 2 is equal to -5. Now here is an example of a square root that is equal to a negative number. A square root will never produce a number that is negative. So this is actually no solution. It can't happen. Now, if you didn't recognize this and you still went on with this problem and squared both sides, you would still arrive at the same answer, and I will show you that in a second. But just know, if you have an isolated radical equal to a negative number, you can actually stop. There's no more work, and you can answer that this is no solution. No values of x will make this true. If you didn't see that and you went further to the next step, and when we square both sides, so you'll end up with 3x minus 2, because the square and the square root cancel each other out, is equal to 25. You're still able to solve for x. So you get 3x is equal to 27, so x is equal to 9. Now, you're probably asking yourself, well, if there's no solution, why did I get a value for x? Well, just remember, our final step for all of these square root equations is that you have to check your answer, because this might be an extraneous solution. So when we check it off to the side, I always plug into the original. So we have the negative square root of 3 times 9 minus 2 is equal to 5. -1 times the square root of 27 minus 2 is equal to 5. So we have the negative square root of 25 is equal to 5. If you simplify this, we actually get -5 is equal to 5, which is not a true statement, which means 9 is extraneous. Since that was the only value of x that we were able to get, and it's extraneous, that means we have no solution. So do you see? You still arrive at the same answer. You're just going to have to do a lot more work if you didn't recognize right away that it was equal to a negative number. All right, so now let's take a look at example 3. So again, we're going to start this process the same. What makes example 3 a little bit different than the other two that we've done is that we have an x underneath the radical, but we also have an x outside of that radical. It's not going to change how you're starting this problem. It's just going to require you to do a little bit more algebra later on. So first step always is to isolate the radical. So right now we have that x plus the square root of 6 minus x. So we want to isolate that 6 minus x, or the square root of 6 minus x here. So I'm going to subtract that x from both sides. So we get the square root of 6 minus x is equal to 4 minus x. The square root is isolated. Now normally this is where we check to see if it's equal to a negative number. You can't do this in this problem because we don't know what it's actually equal to, since there's also an x on the other side of the equal sign. So this makes checking your answers at the very end very important, since we're not able to do that initial step right away. So we're going to skip that step, and we're going to still square both sides. So when you square a square root, All that's left is what's underneath. Now this is the place where we have to be careful. When you see a quantity squared like this, so we have 4 minus x quantity squared, you have to remember that this is asking you to FOIL. So when you see 4 minus x quantity squared, it's actually 4 minus x times 4 minus x. Okay, so FOIL that out. Remember, first outers, inners last. So we have 4 times 4, which is 16. Then we have a minus 4x, another minus 4x, and then plus x squared. Now, this is what I was talking about, where we need to do a little bit more algebra to solve this problem, because we have an x squared now, which indicates that we're probably going to have to factor later on in order to solve for x. So what I would do first is get everything on one side of the equal sign, because in order to factor, your quadratic has to be equal to 0. So I'm going to combine some like terms first. And then move the 6 and the x over. So we're going to have 0 is equal to, I'm also going to change the order here so it looks more like a quadratic that we're used to. So we have x squared minus 7x plus 10. So this is an example where we can just do the sum product rule. What are two numbers that multiply to 10 but add up to a negative 7? So that'll be x minus 5 times x minus 2. And when we solve, we're going to get x is equal to 5 and x is equal to 2. So now please do not forget, we are not done. Don't just circle these answers and move on to the next problem. You must check your answers because there might be some extraneous solutions. So I would go back to the original, plug in, and make sure each value works. So I'm going to start by plugging in 5 to the original. So we have 5 plus the square root of 6 minus 5 is going to equal 4. So 5 plus the square root of 1 is equal to 4. Square root of 1 is just 1. So this ends up being 5 plus 1 is equal to 4, which clearly does not work, which means 5 is an extraneous solution. It's not going to make sense. So we need to cross that value out. Now let's check the 2. Just because the 5 doesn't work doesn't mean the 2 automatically works. You should still check both answers. Sometimes you'll have a case where they both do not work. So don't just assume that 2 is the correct answer. Okay, so we have 2 plus the square root of 4 is equal to 4. Square root of 4 is just 2. So we get a true statement, and 2 is a solution. Okay, so for now, I would like you to pause this video and try examples 4, 5, 6, and 7 on your own. You can check the key that's posted if you're unsure with anything, but I want you to try them on your own first, and then you can come back to this video to finish up the notes. Alright, so hopefully you guys took some time to try these 4 examples on your own. I did provide the solutions here, but like I said earlier, they're also going to be posted, so you can check your answers there. If you were okay with these problems, you can skip this part and move on to example 8 and 9, and I will go over those in a minute, but just a couple things I wanted to point out from these examples. So example 4 and 5 are actually very similar. You first have to isolate the radical. In both cases, there's a negative 1 in front of those radicals, so I divided that negative 1 over before I squared both sides. When you square both sides, please remember to FOIL. That's usually a very common mistake that people make. When you FOIL that, you're going to end up with quadratics in both cases that you're going to have to factor. Both of them just use sum products. So like for example 4, you needed 2 numbers that multiply to negative 15 but added to a negative 2. For example 5, it was two numbers that multiplied to 12 but added up to negative 7. And finally, I did not show the work here. The work is on the key that's posted. Make sure you check these answers. Plug them into the original. For example 4, 5 does not make sense. It's an extraneous solution, so you need to cross it out. The only valid solution is negative 3. And for example 5, both 4 and 3 do work when you check them. So again, make sure you do not forget to check. For example 6, I'm hoping that you guys did not do too much work for this problem. If you notice, the square root is already isolated, so you didn't have to do work for that. But if you also noticed, you see how that square root is equal to a negative 3. So like we talked about on the front page, when it's equal to a negative, there's no solution to this because a square root can't equal a negative number. Now, if you did not recognize this and you squared both sides and you went ahead and and you solved for x, make sure when you check those answers, or make sure that you check those answers, because those values of x will actually not work. So you will still end up with no solution. So no matter how you did this problem, whether you did the whole process out where you're squaring both sides and solve for x, or whether you recognized it that it was equal to a negative number right off the bat, you should still end up with no solution. And example 7 was pretty straightforward. Again, it was already isolated, so you had to square both sides. Just here's another common mistake: when you are squaring a 4x, you have to square the 4 and the x, so you get 16x squared. And then here we have a binomial, but I approached it the same way, and when you factor out a GCF, you end up with an x squared minus 16, which is an example of difference of squares. And when you check, negative 4 does not work. All right, so now we're going to cover example 8 and 9. Notice they do have stars next to them. You could probably tell why. In both of these cases, there are multiple square roots within this equation. We're still going to start the process the same, but when we're isolating a radical, you actually are going to choose one of the radicals to isolate first. So it actually does not matter which one you choose first. So for example 8, I'm going to isolate the square root of x plus 3, which means I'm going to move the square root of x minus 3 to the other side. So because this is a plus sign in front, you're actually just going to subtract that square root over to the other side. Once it's isolated, you're going to square both sides, just like normal. So when you square a square root, again, those two cancel. You're only left with what's underneath. Now here is the tricky part. Please remember, you do have to FOIL this, but you are foiling with a radical. So please be careful, and I will show you what this would look like. So we always do first, outers, inners, last. So first, that's 3 times 3, which is 9. The outers is going to be 3 times a negative square root of x minus 3. You cannot multiply an integer and a radical together, so instead you're just multiplying the numbers in the front. So it'll be negative rad 3 times the square root of x minus 3. For the inner terms, we have the same thing, negative square root of x minus 3 times 3, so that's just another negative 3 rad x minus 3. And for the last terms, we have negative square root of x minus 3 times a negative square root of x minus 3. So a negative times a negative is a positive. And before we multiply the square root of x minus 3 times the square root of x minus 3, I just want to remind you of a little bit of a trick. So off to the side, if you remember, if we did the square root of 3 times the square root of 3, technically that's the square root of 9, which is just 3. If we did square root of 2 times the square root of 2, isn't that the square root of 4, which is just 2. So here's the shortcut. If you remember, when you are multiplying two radicals that are exactly the same together, the trick is, isn't it just going to equal what's underneath that radical to begin with? So when you multiply the square root of x minus 3 times the square root of x minus 3, what's going to be left is just what's underneath that radical, which is x minus 3. Okay, now from here, let's combine some like terms. You probably noticed we still have a square root in the problem, so we'll get to that in a second, but I just want to clean this up a little bit and combine some like terms. So I want to move the x's over and move all the constants over that we have so that we are condensing this a little bit. So when you move the x's over, they actually cancel. So we can cross those out here. So now we have 3 is equal to, we have 9 minus 3, which is just 6. And these are actually like terms. So we have negative 6 times the square root of x minus 3. I'm going to move that I'm going to move that positive 6 over. So we end up with negative 3 is equal to negative 6 times the square root of x minus 3. So because we still have a square root in the problem, we have to repeat the process of isolating that radical again and squaring both sides. That's the only way that we're going to get rid of this last remaining radical. Now, the problem with this is if you try to isolate this, if you divided that 6 over, we would end up with a fraction. If you're comfortable working with fractions, that's fine. You can do that and then square both sides. But if you're not comfortable with fractions, you don't actually have to isolate it completely. What I am going to do is, because we have that negative 3 and that negative 6, I'm going to divide both sides by a negative 3 so that we can reduce those numbers a little bit so our numbers aren't as large once we start squaring things. So when we divide both sides by negative 3, we're going to end up with 1 is equal to 2 times the square root of x minus 3. Now again, I'm not fully isolating this because if I divide that 2 over, I'm going to deal with a fraction, and I really don't want to square a fraction. So we're going to square it from right here. Now there's just one thing that you have to remember when you square both sides. So 1 squared is just 1. When you square 2 times the square root of x minus 3, you have to first square the 2, which is 4, and then you have to square the square root of x minus 3, which is just x minus 3. And please remember, they're being multiplied together. Do not add in an addition sign. That's a mistake I see a lot. When it's 2 times the square root of x minus 3, when you square it, they're still going to be multiplied together. Now that we were able to get rid of that radical, we can distribute the 4 and solve for x. So we're going to get x is equal to 13 over 4. Please remember to check your answer at the very end. So you're going to go back, and you could do a lot of this in your calculator. If you wanted to change 13 over 4 to a decimal to make it easier to work with, you can do that as well. But you're going to get 13 over 4 plus 3 plus the square root of 13 over 4 minus 3 is going to equal 3. If you type that in and simplify that, you will find that that does work, so 13 over 4 is a solution. Example 9 is very similar to example 8, so since there's 2 radicals in this equation, just pick one to isolate. So I'm going to start by isolating the square root of 4x plus 1 and subtracting the square root of 3x minus 2 to the other side. So now that I have one isolated, we're going to square both sides. Please remember to FOIL that right side. So we're going to end up with 4x plus 1 is equal to, now if you need to write it out separately, do it. So it's this 5 minus the square root of 3x minus 2 times 5 minus the square root of 3x minus 2. So when we FOIL, we're going to get 25 minus 5 times the square root of 3x minus 2, then minus another 5 times the square root of 3x minus 2. And since we have negative square root of 3x minus 2 times negative 3x square root of 3x minus 2, we're going to have positive 3x minus 2, because when you multiply the same radicals together, you're really just left with what's underneath. So our next step is to combine some like terms, and we want to then isolate that leftover radical. So first thing I'm going to do is combine the like terms on that right side. So we have 25 minus 2, so we have 23. We have a positive 3x, and we have minus 10 times the square root of 3x minus 2. I'm going to subtract the 23 over, subtract the 3x over, so we're going to be left with x minus 22 is equal to negative 10 times the square root of 3x minus 2. Now, again, normally when we isolate the radical, we would like to divide that negative 10 over, but if you were to do that, you're going to be left with a pretty ugly fraction, and I don't want to have to square that fraction. So I'm going to leave it as is. We isolated the radical as much as we could without making this more difficult, and I'm going to then square both sides again. Now here, because you have two terms being subtracted and that whole quantity is being squared, you want to make sure that you FOIL that again. So we have x squared minus, it'll be minus 22x, and then another negative 22x, so we get negative 44x plus 484. I did a lot of that in my head, so just remember all I did was x minus 22 times x minus 22 and FOILed it from there. Now on the right side, we first want to square the negative 10, which is 100. Then we want to square that radical. So when you square the square root of 3x minus 2, you're just left with 3x minus 2. And that 100 and that 3x minus 2 are getting multiplied together. So now I'm going to distribute. So we are left with 300 x minus 200, some big numbers, but that's okay. Let's get everything. Now, if you notice, we have an x squared in this case, so we are going to have to do some factoring in order to solve for x. And since we're going to factor, we have to get everything equal to 0. So we're going to bring everything over. So we're going to have x squared minus 344x plus 684 is equal to 0. So to factor this, we're looking for two numbers that multiply to 684 but add up to negative 344. This one, because the numbers are so big, it seems difficult, but it's actually just negative 2 and negative 342. So we're going to get x is equal to 2 and x is equal to 342. Yes, these problems are very long, and no, just because we solve for x does not mean we're done. We still have to check our answers. So again, I would go back to your original, and I would plug in 2 to the original. Just going to fix this. So plus 3 times 2 minus 2 is equal to 5, and then you're also going to plug in 342 It is okay to use your calculators to help you with this. Okay, and it turns out that when you plug in 342, that one does not work, and x equals 2 does.